It is possible to be misled into believing that Mars is a place devoid of activity based on photographs taken across its corroded surface. Desolate, dusty terrains appear to extend in all directions, with only stray fragments of rock and the faint howling of the wind serving as barriers against the nearly oppressive solitude. However, if you remain on this crimson planet for some time, you will notice an impending wall of dust and sand that is towering over you. One might naively perceive this dust storm as analogous to those observed on Earth, oblivious to the fact that its magnitude is imminent, to the extent that its dense dust will engulf not merely a continent, but the entire planet. This all-encompassing superstorm typically develops on Mars every 3 Martian years, or approximately 5.5 Earth years. Its suffocating dust obstructs light for weeks, if not months, and poses a formidable obstacle to the continued operation of any technology we deploy there. In the event that Homo sapiens ever desire to establish habitation on the Red Planet, we shall confront this obstacle. This is problematic, as there is still much unknown regarding the origins of these cyclones. Hello everyone, welcome back. You are watching Zeey, the Space Fanatics. Join with me today as we explore the current understanding of the characteristics, mechanisms and impacts of Martian superdust cyclones, as well as the knowledge that terrestrial beings would need to survive one. Mars was not previously subject to dust cyclones of planet-scale magnitude. While Mars presently exhibits a desolate and arid appearance, it formerly possessed a substantial atmosphere of sufficient warmth to sustain the activity of moving water. However, Mars dehydrated and its atmosphere drained away over the course of its billions of years of existence, until its volume was less than 1% of that of Earth. However, those dust cyclones did not suddenly begin to occur when Mars became arid. While the complete understanding of the origins of such cyclones remains elusive, it is postulated that Mars' temperature plays a pivotal role. With less atmosphere, Mars' heat retention significantly deteriorated, despite the planet's elevated CO2 levels. As soon as the surface begins to chill, the escaping heat is not captured by the air. At this precise moment, an individual positioned at the equator of the planet during its warmest period of the day might experience a temperature of 23 degrees Celsius in their feet, with a cranium temperature of 0 degrees Celsius. Mars experiences significant variations in temperature throughout the day and night. At present, the temperature ranges from approximately 27 degrees Celsius during the day to a frigid -133 degrees Celsius at night. The formation of winds due to a difference in temperature can result in the distribution of various weather systems throughout the globe. Dust cycles, rather than rain and precipitation cycles, are currently responsible for Mars' arid climate. Mars is an unexpectedly critical planet, as the formation of those planet-spanning cyclones is highly probable in its absence. Although the atmosphere may be insufficient for heat absorption and transport, the Martian soil is an entirely different matter. Everything begins with Martian particles entering the atmosphere. A number of mechanisms contribute to this phenomenon. One is dust tornadoes, which Mars encounters in the thousands annually, most frequently during the spring and summer seasons. As a result of the ground being heated by the sun's warm rays, the air immediately beneath it rises and frigid air from the atmosphere is drawn in to fill the void. Although many are considerably smaller, these opposing winds generate ascending air spirals that can attain dimensions of hundreds of meters in width and 8.5 kilometers in height. Irrespective of their dimensions, these celestial bodies traverse the vast deserts of Mars, absorbing dust and subsequently expelling it into the atmosphere, thereby generating a faint haze that obscures the morning sky. It is hypothesized that this process contributes to the perpetual presence of a miasma of background material in the atmosphere of Mars. Although this is the most conspicuous method through which particulate enters the atmosphere, it is not the most widespread. The process of saltation, which is caused by the straightforward influence of wind passing across Mars' dusty surface, is far more prevalent. Surprisingly, it is difficult to propel Mars dust into the atmosphere. This is because small particles, which are slightly electrostatic and therefore have a high degree of cohesion, similar to packing peanuts, they adhere together, require a certain amount of momentum to move. Ironically, greater particles are more susceptible to wind propulsion due to their reduced cohesion. Thus, gusts of wind elevate these larger sand grains, which are subsequently transported over brief distances. However, due to their ultimate weight surpassing the wind's ability to suspend them, they descend once more. The momentum generated by these minute impacts is sufficient to surmount cohesion and propel the lighter dust into the atmosphere. However, due to Mars' lower gravity, dust can easily persist in the planet's atmosphere for weeks or months after it has reached the surface. This is sufficient to initiate the development of cyclones. This is because, in contrast to the surrounding sparse air, dust particles are exceptionally efficient at absorbing solar radiation. Dust particles in the atmosphere function as miniature radiators. As the sun warms them, they gradually release the accumulated heat into the surrounding air, where it would have otherwise permeated to the ground. As a result, the surrounding atmosphere becomes considerably heated. Warm air rises, but it is now doing so on a significantly larger scale than when it first formed dust tornadoes. Wind must be drawn in from the sides of the ascending air mass. However, this serves to fuel the fire further. Increased wind velocity results in heightened saltation, increased particulate dispersion into the atmosphere, and an expanded potential for atmospheric warming. This haphazard process culminates in a dust cyclone that spreads throughout the region. The good news is that a dust storm on Mars is not particularly hazardous in and of itself when viewed on a local scale. Maximum winds of 97 km per hour are less than half the velocity of hurricane winds on Earth. Furthermore, this statement is deceptive. The atmosphere's thinness renders it imperceptible even when it is moving at high speeds. Similarly, an individual's pushing force is less than that of an entire throng. In contrast to the depictions in science fiction works that revolve around Mars, dust storms lack the destructive potential to topple spacecraft or shatter satellite antennas. Nevertheless, these cyclones present their own unintended perils. Solar-powered Martian rovers would be in for dire straits if an abrupt dust storm abruptly passed overhead, carrying electrostatic dust particles that are only slightly adhesive. Over time, the accumulation of dust from these cyclones has become significant, impeding the solar panels of rovers and ultimately leading to the termination of multiple missions from Earth. The issues, however, become increasingly complex as the scale of these cyclones increases. The orbit of Mars is not precisely circular. During the spring and summer seasons of the Martian southern hemisphere, the planet is at its closest approach to the Sun and experiences its highest average temperature. We do not completely comprehend why, but at this time of year, superstorms the size of continents begin to form from regional dust storms. Naturally, there is also the possibility that multiple cyclones began to merge simply by their proximity and began to form coincidentally. Although their recurrence suggests that coincidence cannot account for them, this is not the case. In fact, they occur annually, as if by magic, as soon as the temperature rises to a certain level. Those are only the ones that are continent-sized. Scientists have yet to discover an explanation for the subsequent stage, which consists of cyclones the size of planets. These phenomena transpire at intervals of 3 Martian years, a duration seemingly brief enough to exclude the possibility of Milankovitch cycles being their source, given that these processes typically operate over periods ranging from thousands to hundreds of thousands of years. Is it possible that a component of the dust cycle requires restocking every 3 Martian years, or approximately 5.5 Earth years? We truly do not know. Although the average duration of dust cyclones on Mars is a few days, these storm apexes can persist for weeks. The cyclones have the potential to cause significant damage to human technology across the globe. The assessment of sunlight availability on Mars can be accomplished through the utilization of aerosol optical depth, AOD, which quantifies the amount of sunlight that is obstructed or obscured by airborne pollutants. On average, the AOD on Mars is approximately 0.5. In order for rovers such as Opportunity or landers like InSight to recharge their onboard batteries, the AOD must be below 2. The dense smoke that initiates the transition from day to night, resulting from a terrestrial conflagration, has an AOD of 7. AOD for these planet-sized dust cyclones ranges from 9 to 11. They constitute an almost complete obstruction of light. A tempest of this nature destroyed the Opportunity rover in 2018 by inundating its solar panels with water and putting it into hibernation. The rover remained dormant due to a critical component breaking down during the drastically fluctuating day-night temperatures that occurred in the absence of power to its onboard heaters. These cyclones also pose a challenge for other rovers, including those equipped with onboard nuclear batteries such as the Curiosity. Due to the fact that the clouds are sufficiently dense to obstruct communication to and from the surface, scientists are compelled to wait them out. Still, that is not all. Satellites are not immune to the effects of these cyclones. The expansion of the entire atmosphere is caused by the enormous quantities of warming material in the air, which some of it enters via the orbital paths of satellites. They are compelled to waste valuable fuel adjusting their course in order to prevent atmospheric drag from causing them to plummet from the Martian atmosphere. In order to establish human settlement on Mars, one would be required to devise strategies for surmounting the challenges outlined above. Without backup power sources, solar-powered communities would perish in such cyclones, and human beings do not fare well in such sub-zero temperatures. A disruption in communication with our satellites would additionally result in our seclusion and susceptibility during that limited time period. Due to the fact that one would be unable to summon for assistance in the event of a storm, individuals would be required to possess a certain level of self-reliance. However, over time, these disasters ultimately result in their own demise. Over time, obstructing an excessive amount of light will prevent the surface from warming to the point where it ceases to generate the upswelling breezes that initially propel the dust into the atmosphere. In the absence of additional dust ascent, these cyclones dehydrate and diminish in intensity, returning quietly to the red planet. Things remain unchanged once more. Survivor rovers are now able to emerge from hibernation and recommence their scientific endeavors, having restored communication with Earth. As of 2023, 3 rovers are operational on Mars: Zhurong, operated by China, Curiosity, and Perseverance by NASA. Zhurong is the only one among the 3 that employs solar panels as a means of generating power. It will require extreme caution. The previous superstorm occurred in 2018. Considering the average occurrence time of 5.5 Earth years, the subsequent one may transpire in the near future. A small amount of wind will commence, causing some dust to become stirred, and the cycle will once again commence. Alright guys, that is all for this video. Thanks for watching. If you find this content valuable, give it a thumbs up and subscribe to the channel and ring the bell so you don't miss our daily videos.